So guys, in this video we are coming to the last concept of a surface chemistry called as application of colloids. So basically first and the foremost thing we will be seeing the application in our industries. So as soon as we coin the term as industry, the first sight or an image that comes before our eyes is that of your pollution and majorly contribution to that of your air pollution. So in this industry's part, let us see that how we can apply the knowledge of the colloids in order to reduce this air pollution. Remember, whenever a smoke which is been emerging out of the chimneys of your industries, remember that your smoke is a colloidal solution. Yes, whatever we are talking about is smoke. Of course, we have seen this. This is actually a colloidal solution. So how does this forming a colloidal solution? Basically, it's a colloidal solution of solid particles. Solid particles. That solid particles may be your carbon, it may be your arsenic compounds, yes, or it can be also your dust. So these are actually your smoke content. So in order to decrease its concentration, we are adopting a method which is called as electrical precipitation of smoke. Electrical precipitation of smoke. So what we are doing it, let us see. So basically, whatever we are talking about the smoke, we have come to know that it is a colloidal solution of the solid particles of your carbon, arsenic compounds and the dust. So of course, whenever the concept of the colloidal particles emerges, we come to our mind, colloidal particles will be associated with some sort of a charges. Similarly, here also the smoke or the pollution, what we are talking about, it will be also assigned some type of a charge on it. So what we are doing means basically we are making the smoke to pass into a chamber. So the smoke is passed into the chamber. So in this chamber we are having two oppositely charged electrodes. Yes, what we are having. So in this chamber what we are having is an electrically charged electrodes. So depending upon the charge on your smoke or the dust particles, of course it gets mutually coagulated with its oppositely charged electron plates. So once they are going and sticking to that of their respective electrodes, what happens? It forms a precipitate. Precipitate and artha a sooth hange iruttalva that will come and settle at the bottom instead of flying in the air. Alva, this is very much important. Air alli one gas untu andre it is very much harmful. But in case if we are making it converting into a solidified form, of course we can preserve it or we can collect it. The same scenario is over here. Colloidal particles smoke in the yake dangerous because it will be flowing throughout the air and it can also obstruct your nostrils and many hazardous effects can occur through that smoke. So what is the main tendency we have to do is instead of making it as a continuous motion of this smoke, we have to precipitate as a sooth. So how can you do it? Of course, smoke is a colloidal solution which will be having some specific charge. It will be passed into a chamber. In that chamber, you will be having two oppositely charged electrodes. So depending upon the charge of your smoke, what happens? It will get attracted by its oppositely charged electrode. Of course, it will be formed a precipitate and it will be collected at the top of your bottom of your chamber. So easily that can be taken off. That is the major criteria. So basically this electrical precipitation of the smoke is also called as a cotral precipitator antanu heltivi. Cotral precipitator. So majorly what is the phenomenon in this cotral precipitator is a coagulation. Coagulation of your smoke particles. Coming to that of your paints, if you talk about some other criteria, so what we are using in the industries, the paints, even your inks, and that of your synthetic plastics, rubber, graphite, lubricants, cements, whatever the industrial particles we are using, they are all colloidal solutions itself. Coming with respect to the most important aspect, that is your purification of water. Purification of water. Of course, whenever we are seeing the water, we could see certain particles are moving. Alva illa tumbane common agi nodbeku andre ee mud water na tagondaga, of course we can see what it is having a brown color. Alva brown color irutte. Yake brown color irutte? Because whatever the dust particles are there, they will be acting as a colloid, or the sand particles which is present in it, they will be acting as a colloid. So they will be moving in a continuous random motion. But we have to make it, or we have to purify it and the of course the phenomenon of your coagulation itself. So the water whichever we are obtaining from the natural sources, they often will contain some suspended particles. So for that natural source of water, we will be adding our alum to it. Alum. So when alum is added to such water, what happens? Of course, it is going to interact with that of your suspended particles. So once it gets interact means what happens? Oppositely charge getting interacted. Of course, your impurities get settled at the bottom. And whatever the upper part of your tub will be having, that will be having the purest drinking water. So this is one of the method of the purification of your drinking water using the concept of your colloids. If you're having a tub and this is your natural water. So in this natural water, what happens? You will be having some suspended particles. Alva, yeah, water color because all the particles will be moving. So that is the reason it is having that muddy type color. So in order to purify this water, what we are adding, an alum we will be adding, which will be having some opposite charge compared to that of your colloidal particles. So the phenomenon of your coagulation takes place. Once it coagulates, what happens? All these suspended particles, instead of moving, they form a bulkier particle and they get settled at the bottom. Once they get settled at the bottom, whatever the upper part you are having, that will be a purified water, which can be used for your drinking purpose. So this is another application of your colloid, which is under the concept of your purification of drinking water. The most important phenomenon is that of your medicines. Where is your medicines? In medicines, how it is used. So coming with the aspect of your medicines, basically most of your medicines are colloidal in nature. For example, the common medicine, I don't know how many of you uses, argyrol, basically. So it's a silver salt. It is a silver salt. Basically, they are used in your eye lotion. Yes. Coming to that of your colloidal antimony. Colloidal antimony. Basically, these medicines are used for the treatment of your disease like your calazar. Similarly, your colloidal gold. Remember colloidal gold. So they are used in your intramuscular injections. Intramuscular injection. And the most common thing which we have used was called as that of your milk of magnesia. Milk of magnesia. Basically, it is also colloidal in nature, which is used for that of your stomach disorders. Stomach disorders. Now, when we are talking about the medicines, basically we could just see that all your medicines are colloidal in nature. Alva. So one common thing which comes to our brain that, of course, sir, why can't we use the medicines in a bulk quantity or in a particle size to be having somewhat greater in size? Remember, one of the most important advantage of medicines in its colloidal form is that these colloidal medicines are very much effective. Only because of their large surface area, and second most important, due to a smaller size, they can be easily assimilated or digested in your system. That is the main common thing. So when you're taking a bulk apart, it will be very much hazardous for our body to get digested. But when you're taking it in a whenever we are taking a medicine, it will be in a smaller quantity, and in that smaller quantity, their size will be very much small. So one of the two important reasons for its good advantages is, one is its larger surface area, and the second most important thing is it is easily assimilated in our body. That is the reason our medicines will be colloidal in nature. Coming to that of your tanning, a process of hardening of leather, leather purse, leather belts, leather wallets, whatever we are choosing, they are made up of that of your animal skin, animal hide and the head. Of course, whenever we are taking that animal hide, of course we have touched the skin of them. It's going to be very smooth. But when you are considering this leather belts or leather wallets or leather purse, basically they will be somewhat hard. So here also we are using the concept of your colloids. Basically, whatever the animal hide we are extracting from the animals, they are positively charged colloidal particles. Remember, whatever the animal hide we are taking or we are extracting or we are peeling, we can say, it is basically what? Positive charged colloidal particles. So in Martivi, positively charged colloidal particles, now we are soaking it in a tannin solution. Tannin, a solution in which your animal hides will be soaked. So even tannin, this is a negatively charged colloidal salt. Of course, positive is interacting with that of your negative. What happens? Mutual coagulation takes place. Once this coagulation takes place, what happens? Whatever the animal hide, the smoothness of the animal hide will be there. That will get hardened. So that is getting hardened. That is the reason whatever the materials we are purchasing from the shop, they will be having somewhat a rough leathery part. So why it is happening means whatever the animal hide, which is a positively charged colloidal salt, it is first soaked in a tannin, which is a negatively colloidal salt. Due to the mutual coagulation, what happens? Your leather gets hardened. Not only your tannin, nowadays we are also using your chromium salts. Of course, your, what you can say, chromium. Yes, MiUM, chromium salts. Of course, the effect is same, but just we are altering our reactant part or a tannin part now replace the chromium salts. The effect will be same, which is also used for your hardening of the leather. But the most important concept one has to know, whenever we are talking about your animal hide, once again it is a colloidal salt of positively charged. So when it is soaked in that of your tannin, it is a negatively charged colloidal salt, mutual coagulation takes place and your leather gets hardened, which could be used for your economic purpose. Coming to that of your rubber industry, of course alva, rubber industry ಕೂಡ ಈಗ ನಾವು ನೋಡಿರ್ತೀವಿ ಏನಂತ ಕೆಲ rubber plantations ಅಲ್ಲಿ they have been kept a cup and they will be just making a slight mark on the trees, a slight cut on the trees and will be collecting a milk, alva rubber milk or latex ಅಂತ ಹೇಳ್ತೀವಿ. Of course that latex is a liquid in state, alva, is liquid in state. But majorly when we talk about latex, of course, we will be saying that, okay, latex inda naven martivi, rubber na martivi. So how you are doing that rubber? In simple words, how you are converting that liquid to solid? It is once again the application of your colloids itself. Whatever the latex we are collecting from the rubber trees, basically they will be negatively charged. They will be negatively charged rubber particles. ಅದಕ್ಕೆ ನಾವು ಒಂದು ಬೇರೆ ಸಬ್ಸ್ಟೆನ್ಸ್ ನ ಆಡ್ ಮಾಡಿ, so we are adding it and another substance in order to coagulate it. So once you coagulate it, what happens? It gets solidified and whatever you will be getting, that will be a solidified rubber. So these are the certain applications of your colloids. Basically we have seen how in precipitator we are converting your smoke to get precipitated and by your mutual coagulation. Whatever we have seen the application is always involving just one important phenomenon called as your coagulation. Similarly in your purification of your water by the addition of your alum, in your medicines, why colloidal medicines have more advantages? Two most important things. One is its larger surface area and second most important thing is it is easily assimilated. Similarly, when compared to that of your tannin, also we saw your animal hide being a positively charged colloidal salt, tannin being a negatively charged. When you are adding both those two things, of course the coagulation takes place and your leather gets hardened. Coming to that of your rubber industry, also conversion of your latex to that of your rubber, we are adding a coagulating agent. Once the latex gets coagulated, it will be converted to that of your solid rubber. So now guys, this completes your surface chemistry part. But I would just like to focus one of the most important thing in this chapter under the concept of your nanomaterials. Remember, in the present scenario, whatever we are working and whatever the technologies are running is all depending upon your nanometer scale. So whatever the colloidal particles dimension now noted, that is also in nanometer. Now the question arises that why this nanometer or why this colloidal particles are very much important to study. Now note how it is important. But I would like to focus on some of the most interesting things which your textbook has not covered, but I would like to show it in my video. Yes. So guys, these are some of the interesting facts which I have extracted from the Nano World, an introduction to nanoscience and technology by C.N.R. Rao. So basically whatever the colloidal particles we are learning now, it is not the thing which has been developed 2 to 3 centuries back. You can just see in this book they have written, nearly in the 1612 itself, they have got an idea called as an Antonia Neri, where he proposed we can say a journal, a treatise, and called as an LRT Varia, where he has described the synthesis of colloidal gold. Of course, but a greater contribution of the colloidal materials came into existence only after your 1857, that of Michael Faraday. So what he did, he had made a breaking work on the called as a divided metals. So Faraday basically identified an essential nature of your colloidal metal particles. Why I'm saying this? Because remember guys, so for example, when I'm choosing my gold particles, when I'm choosing my gold, of course what happens, the bulk gold is what nearly it is in golden color. Now when the question arises, when I am taking the bulk gold and I am converting into a colloidal dimensions, colloidal gold sol na prepare martini. Now the question arises whether the color remains same or whether the properties remains same. Alva ivella namge ಒಂದು question arise ಆಗೆ ಆಗುತ್ತೆ. Remember, as the particle size goes on decreases, your color also goes on changes, and also your properties also goes on changes. That is the reason I just wanted to show it so that you can have a better imagic view captured in your eyes. So actually he was called as a Michael Faraday. He was the one who has introduced this colloidal gold salt. You can just see that he stated that gold is reduced in exceedingly fine particles which are becoming a diffuse, produce a beautiful fluid. You can just see the color of the gold salt he has prepared. Can you see? It is having a pink color instead of having the golden color. Even the as the size is going on decreasing, your color also goes on changes, and also the properties also changes, which I am going to show you in my next pages itself. So now also this has been preserved in a Royal Institution of London. So basically it was Michael Faraday who gave us the clear-cut knowledge of your colloidal gold salt. Yeah guys, now you just read this statement. So if you take a material like iron or any material which is magnetic and go on decreasing the size of the particle, the properties will change. They lose their magnetism when the size is very small. You can just have a hint. Here we are getting one hint that what? As the size is getting decreased, what is happening? The properties are also changing. Similarly, the gold shines as a metal. However, when we make very tiny particles of your gold of 1 nanometer diameter, you can just see what they have written. They are no longer metallic. Metal property ne adu bitkodta untu. They do not shine like that of your bulk gold. Bulk gold is not chemically reactive. Remember, bulk gold enuntu, that is not chemically reactive. That is the reason we are making a jewelry of gold. But what happens as soon as its particle has been reduced, of course it is no longer metallic, and the most important thing, it becomes chemically reactive. Bulk gold was not chemically reactive, but as the size is going to that of your colloidal range, you can just see the statement what they are saying. It is becoming chemically reactive. Of course the property anta heladnala, property yav tara change agutte nodi. Illa avaru ಒಂದು graph ಕೊಟ್ಟಿದ್ದಾರೆ. ಏನು ಹೇಳ್ತಾರೆ? The melting point of a solid changes when we make tiny particles for the material. They have also given a good example over here. Small particles of gold melt at a much lower temperature than the big piece of gold. Can you see this is a bulk gold? Can you see its melting point? Nearly 1064 degrees Celsius. So they have plotted a graph of particle radius. 1 nanometer in the 11 nanometer. This is your melting point range. You can just see that as the particle size is increasing, what is happening? Your melting point also goes on increases. That means what? If I am having a smaller metallic particle of gold particle, remember of colloidal range, you could just see that it will be having the melting point at a very lower temperature. The most interesting fact of the properties can be learned over here. Size of the particles, yav tara nama range al kotide, yav tara adu properties distinguish agutte anta. So remember, whenever we are having the particle size say 50 nanometer and the above, this is your region 1. So ಏನು ಹೇಳ್ತಾರೆ, their properties will be similar to those of the bulk. ಬಲ್ಕ್ ಅಲ್ಲಿ ತಗೊಂಡು ಅಥವಾ ನಿಮ್ಮ ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ 50 ನ್ಯಾನೋಮೀಟರ್ ಗಿಂತ ಜಾಸ್ತಿನೇ ಇರಲಿ, ಅವಾಗ ಏನಾಗಿರುತ್ತೆ, ಪ್ರಾಪರ್ಟೀಸ್ ಸೇಮ್ ಆಗಿರುತ್ತೆ, ಬಲ್ಕ್ ಅಷ್ಟತ್ರನೇ ಇರುತ್ತೆ ಅಲ್ವಾ. ಬಟ್ ನಾವು ವೆನ್ ದಿ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಫಾಸ್ಟ್ ಅರೈಸಸ್ ಓವರ್ ಹಿಯರ್, ಸೊ ವೆನ್ ದೇ ಆರ್ ಆಫ್ ಲಿಟಲ್ ಸ್ಮಾಲರ್, ಸೇ 10 to 50 nanometer, their properties may vary linearly. The second range, ಇಲ್ಲಿ ಆ ರೇಂಜ್ ನೋಡ್ತಿದೀವ, ಫಸ್ಟ್ ಈ ರೇಂಜ್ ಇತ್ತು, ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಹೋಗ್ತಾ ಉಂಟು ಬಲ್ಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ಜೊತೆ. ಆದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ ಲೀನಿಯರ್ ಆಗಿ ಹೋಗ್ತಾ ಉಂಟು. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು? As you are increasing the size, the properties also goes on changes. But the most interesting part I want to just notify on this third range. ಇದನ್ನ ನಾವು ರೇಂಜ್ ನ ಯಾವ ತರ ಹೇಳ್ತಾರೆ ಅಂತ ನೋಡೋಣ ಫಸ್ಟ್. ಸೊ ಬೇಸಿಕಲಿ, however, when the size becomes very small, we get some unusual new properties. So here we see actually the quantum effects, which you will be seeing in your higher classes also. And yaki properties change ಆಗ್ತಾ ಉಂಟು? It is mainly because electrons are confined in a small volume. ಅಲ್ವಾ? ಒಂದು ನೀವು ಬಲ್ಕ್ ಆಗಿ ತಗೊಂಡಾಗ ಏನಾಗುತ್ತೆ, ಅಫ್ಕೋರ್ಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಒಂದು ಸ್ಪೆಸಿಫಿಕ್ ವಾಲ್ಯೂಮ್ ಅಲ್ಲಿ ನಿಮ್ಮ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಅದೇ ಬಲ್ಕ್ ನ ನೀವು ಮುರ್ದಿ ಬ್ರೇಕಿಂಗ್ and you're making a tiny particles, what happens, that electrons has to be get confined in a small volume, and you can just see how it will be changing its properties. We are not able to judge, ಅಲ್ವಾ? ಇಲ್ಲ ಆದ್ರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುಂಟು, ಇಲ್ಲಿ ಲೀನಿಯರ್ ಆಗುಂಟು. ಅದೇ ಥರ್ಡ್ ರೇಂಜ್ ಅಲ್ಲಿ ನೋಡಿ, it is like in a zigzag manner. We can't predict itself. Why I am showing this? To make sure that it should kept in your mind. Yes, colloidal particles is not the thing what we are learning in the bulk. ಈಗ ನಾನು ಬಲ್ಕ್ ಗೋಲ್ಡ್ ನ ನಿಮ್ಗೆ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟು ಹೇಳಿದೆ ಏನಂತ, ಅದು ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ನ ಸ್ಟಡಿ ಮಾಡಿದೆ. ಎಷ್ಟು ಬಂತು? 1069 ಬಂತು. ಅದು ಕೆಮಿಕಲಿ ರಿಯಾಕ್ಟಿವ್ ಇಲ್ಲ ಬಲ್ಕ್ ಗೋಲ್ಡ್. ಅಂಡ್ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಇಸ್ ಗೋಲ್ಡನ್ ಇನ್ ಕಲರ್. Alva, these are the certain interesting facts which we learnt of bulk gold. But when the same bulk gold was reduced into colloidal solution, its color was changed to pink color first. It was not a metallic. Alva, bulk gold was metallic, but with colloidal gold solution, it is not metallic. Most interesting fact, it became chemically reactive, and also its temperature was decreased. That is, its melting point was decreased. What is the knowledge we are gaining from here? Of course, the properties, the color, all are depending upon your size. What it is? The size of your colloidal particles. A color ಬಗ್ಗೆ study ಮಾಡಬೇಕು ಅಂದ್ರೆ you can just see this scenario. So basically, we have taken a cadmium selenide. ಇದು ಒಂದು semiconductor. Okay, it is actually a semiconductor. And if I am going to shine some light through this solution, ಒಂದೊಂದು particle size will ಕೊಟ್ಟಿದ್ದಾರೆ. ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಕಮ್ಮಿ particle size ಉಂಟು. This is all containing a cadmium selenide itself. ಅದು ಏನಾಗಿದೆ, our particle size is varying. So you can just see that when I am putting the torch for the first light, I am getting a red color, then somewhat orange, then somewhat yellow, then green, then blue, then violet. Why I am getting this changes? Only because of the difference in the size of your colloidal particles. One of the most interesting fact we have to remember of this colloidal particles is that colloidal particles, of course, they are having their charges by the preferential adsorption. They're also having their specific properties depending upon their size. Yes. And the most important thing, whatever the charges they are getting adsorbed, it all depends upon the preferential adsorption. You know, preferential adsorption. One of the most interesting book it is basically. In case if you get a time, I will also provide you as soon as the college reopens. So you can come to know that how does our nanotechnology is working. Carbon nanotube. Here bad I chapter. Just is an important thing. If you are having such books in your home, you have a habit to read it. Of course, it's a worthy point to know what are the interesting facts or the technology which is running throughout. Okay. So this completes our chapter of your surface chemistry.